Okay, let's go ahead and get started. So today I want to begin this lecture by addressing a few questions that I've had from students regarding uh, nested for loops and pseudocode. So before beginning this discussion, I want to motivate it with a problem or a task. So camera will, there it goes. Suppose we want to write a computer program to produce a multiplication table. So something like um, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So in this table, uh, the entry will correspond to the row number times the column number. So this is 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5. And then here this would be 2 times 1, 2 times 2, 2 times 3, 2 times 4, and then 2 times 5. Okay? And then here in a similar fashion, 3 times 1, 3 times 2, 3 times 3, 3 times 4, and then 3 times 5, right? And you can fill in the rest as you want, okay? So suppose we want to write a computer program to generate a table that kind of looks like this. Well, we can do this using a nested for loop. So notice that we have one, so if we think of the row entries here as indices, right, we have like maybe, so this would be like I on this uh, column here, and then J on this row here. Notice that in order to make these entries, we can pick either I or J, it doesn't matter, and we can increment I, and at each time that we increment I, we then increment across all of J, right? So it's like, we set I is equal to 1, right? So then this entry is 1 times 1, so I times J. So that gives you that 1 right there. And then we increment J to 2, and it's I times J again to get there. And then we increment J to get to 3, and we get I times J to get that entry. And we increment J up to 5. And then we look back to I, and we increment I to 2, right? So once we increment I to 2, then we increment J all over again. So 2 times, so I times J is there, and then you increment J to be 2, and it's I times J to get that entry, and you increment J again to get to 3, and you get I times J to get to 6, so forth and so on, right? So the way that you can produce something like this would be something like, so for, and we're gonna choose I to be our first index to increment through. So for I equals to 1 to 5, so we pick our I, and then we get to scroll all the way through J now, right? So we're gonna have the second for loop here. For J equals 1 to 5, we can say something like print I times J. Okay? There's a little bit of glare, but inside of the parentheses here it just says I times J. So what's happening here, right? Like, so let's kind of like walk through this nested for loop, right? So again, this is what's called a nested Okay, so if we run through this, right? So we take I is equal to 1, right? So we're inside the for loop now, right? So then J is equal to 1, because now we're inside this for loop, and we're going to multiply those two things together. So we're going to have print 1 times 1. And that'll give you that entry there. But then we're still inside of this second for loop. So then we're going to have I still equal to 1, and now J is going to increment to 2. So then we're going to print 1 times 2. That'll give you that entry there, right? But we still haven't reached 5 for J, so we got to keep on going. So I is equal to 1 still, but now J is going to be equal to 3. Okay, and then we'll print 1 times 3. That'll give you that entry there, right? And we do this until we get I is equal to 1, and then J is equal to 5. That's the very last one, right? And we print 1 times 5, which will give you that entry there. Okay? And then, okay, if you want to have like a new row, maybe, after you exit that for loop, maybe print like a new line or something. So now you're on a new line, and now you want to do this here. So, but now I has been incremented to 2. You're still inside of this top for loop. So then now I is equal to 2, and then you go inside this for loop, and J starts at 1 again. And you want to print 2 times 1. Which should give you that 2 right there, right? But now we're still inside of the second for loop. J is not 5 yet, so we have to increment J. So I stays at 2, and then J is incremented to 2. And we print 2 times 2, which will give us that 4 right there. Okay? Still inside of the second for loop, so I is still at 2, but now J is incremented to 3. And we print 2 times 3. Right? We're printing, I should just put I and J, print I times J, but get what I'm saying. So I is 2, J is 3, so I times J is 2 times 3, which will give us that 6 right there. And we do this up until we get to I is equal to 2, and then J is equal to 5. And then we finally print out I times J, or just 2 times 5, which will give us that 10. So then we exit out of that for loop, we print a new line, and then we increment I, and now I is 3. So then it's going to be I times, so then once I is 3, we go into the second for loop, and then scroll from J is equal 1 to 5, multiplying and printing. Okay? So hopefully that helps understand how nested for loops work. For each variable here, you're going to do whatever is down here. This could be a for loop, a while loop, an if statement. But for each of those indices, I, you do everything inside of here. Right? So I'm pretty sure most of you understand how for loops work. Right? For each I, you do something, right? Well, for each I, everything in here has to be done. If there's a for loop in there, you have to do everything for that J, right? So real quick, let's see if we can program this. So I'm going to have to share my screen. Okay. Let's see. I might have Spider open. Here's spider. Okay. So what do we want to do? We want to print a multiplication table. Okay. So let's just say like, okay, for I in range 10, let's say print I. So let's just like run this. So we get that there. Let's say, okay. So maybe what I can do, let me just check something real fast. Real quick, I forget. I guess that's it. I guess it's just that, n is equal to that. So pulling spider back out. Let's see what happens if I do this. N is equal to. All right, so we see that we got them all like that. So maybe I want to put like a space in between them. So I can put maybe like that, comma. So I'm just putting a vertical line in there, see what happens. Okay, that's kind of close to what I want. Maybe put like a space there. Put a space there. Okay, that's starting to look like I want. Okay, so that's like saying for I is equal 0 to 9. That's what this first for loop is saying here. So but now we want to multiply numbers 1 through something. So maybe if we start at 1 and we end at 10. All right, so we started at 1 and we're ending at 10. Okay. All right, so we want to make the multiplication. So we can say, now we can do for j in range 1 to 10. So the range function stops at this number minus 1. And instead of I, we're going to print I times j. Oh, kind of closer there. Kind of something like this. It's not going to fit. Oh, I see. So what I want to do here, these are all being printed to the same line. I'm going to say print just there. See what happens if I do that. Closer. And that sort of looks like a table, right? Once you get to the double digits, it kind of spreads it out a little bit. But you can kind of see the multiplication table there. Maybe if I get rid of this, it'll look a little bit nicer. I need a space. At least it's there. So that's more or less what I had on the board. Okay, so maybe to make this like a little bit simpler, okay, I'm just going to go up to 4, and then here I'll go up to 6 or something, or 5. So I'm going to say print I. So I'm going to do something called an F string here. It's called a format string. So F, enter in my string, I is equal to, and then this, putting in the curly braces here will convert the value. It'll format this to be a string, so this should print out nicely. So, and then inside of here, I'll say print, use that same F string thing. J is equal to, and then I'll convert J to there. Let's see what that does. It's kind of ugly looking. So this is not making a table. This is, I'm just going to show you how for loops work. So F string. So I times j is equal to, and then I can do I times j inside of curly braces to convert that to a string. So let's see what this does. And I want to maybe put like a there. I'm just trying to format this to where you can see it nicely. So that's still in the outer for loop. Let's run that, see what that looks like. Okay, so what's happening here? So here I is equal to 1, right? So I is going to go from 1 to 4, j is going to go from 1 to 5. See that? So when I is equal to 1, all of these correspond to the case when I is equal to 1. And see how j ranges from 1 to 5? So 1, 2, 3, 4, 5. And I is stuck at 1 because we're in the first iteration of this for loop here, the top for loop. So I stuck at 1. And in here, all of these j's incremented from 1 to 5, so that's inside the second for loop. And then once we exit that for loop, there's nothing else to do besides print 2 spaces. And then it loops back up and says, okay, now I is equal to 2. Okay. So then we say there's I stuck at 2, but j, see j is changing. Right? So maybe it might even be easier to see if I take this guy and put it right there. Yeah, maybe that's easier to see. If you look over here, you see that I is stuck at 1, right? And then j is the thing that's changing. And here I is at 2, and then j changes. I is at 3, and then j changes. I is at 4, and then j changes. And then finally, we stop because I only goes up to 4. Okay? Okay, so that was a slight digression away from what I originally planned to do today, which was talk about bubble sort. So let me say, okay. Okay. So in many contexts, you're given a list of numbers, and it's helpful if that list is in either increasing or decreasing order. For example, when we were looking at our searching algorithms, linear search was slower than binary search, but binary search needed to have a list in increasing order in order to work. So what we're going to talk about now is an algorithm called bubble sort. Okay, and we're going to use an example. Say 3, 2, 4, 1. I know 5, 1. Okay, so our goal, is to sort a list into increasing order. Okay. All right. So we're going to need a nested for loop, but I'm just going to walk through it first, and we'll try to piece together what the pseudo code looks like. So you begin. So there are, say, I'm going to say that this is like A1, A2, A3, A4, and A5. You all see that? Okay. So there's n is equal to 5. N is equal to 5. There's 5 things on our list. So the way that this works is by comparing neighbors in the list to see if one is bigger than the other. And the general goal, or the idea is that the smaller numbers you want to push to the front and the larger numbers you want to push to the back. So the way that we can do this in an iterative nature or fashion is start here and then compare the first entry with the second entry. So in this case, it's 3 larger than 2. So in other words, is A1 greater than A2? Hopefully you can read that. So A1 greater than A2. Is that true? It is. So then we're going to swap A1 and A2. Swap A1 and A2. So then we get 2, 3, 4, 5, and 1. Okay? So now, we now look to A2, okay? So we compare A2 with A3. So is A2 greater than A3? It is. So we're going to swap A2 and A3. Oh no, it's not greater, sorry. So we don't do nothing. So do nothing. Okay, because it's not greater than, A2 is not greater than 3. And then we move down again. So now we look at A3. And we compare A3 to A4. Is A3 greater than A4? It's not. So we don't do anything. Okay. So then we move to A4. And we compare A4. Is that greater than A5? It is. So we're going to swap these 2 entries. Swap A4 and A5. So notice that we've made it to the end of the list. We're at A5 now, right? So we do nothing. So this right here is our new list. It's not an increasing order, but we push the largest element of the list to the very last entry. Okay? So we perform this process again. So starting with this list. So 2, 3, 4, 1, 5. Okay? So now we start here again, and we compare A1 to A2. Is it greater? It's not, so we do nothing. So we move forward again. So now we compare A2, is that greater than A3? It's not, so we do nothing. Okay, so now we compare A3. Is A3 greater than A4? It is, so we're going to swap. So swap these two. But now we can stop. We've made it to the A4 entry, right? And we know that on the previous pass, the A5 entry was guaranteed to be the largest number. So we know we don't have to go any further. We've made it to the fourth entry, we can just stop. Okay? So here, this is our new list. Okay? So in terms of like the number of elements in the list, it looks like we went so we went from A1 to A4. So in this first pass here, it looks like we picked an index. So again, we went from like 1 to 4, which is like the same thing as saying 1 to n minus 1. So we went up to 4 here. And then here we started at the 1 index and we went up to comparing the 3, right? A3 with A4. Here we went to A4 to A5. So now we're comparing A3 to A4 here. So it's looking like 1, 2, 3, or 1, 2, n minus 2. Okay. But now we got to do this again, starting with this list. So 2, 3, 1, 4, 5. So we do the same process over again. So we compare A1 to A2. It's not bigger, so we don't do anything. So then we compare A2 to A3. It is, so we're going to swap. And we'll get 2, 1, 3, 4, and 5. But now we know that that number is going to be the largest of the first pass. This is going to be the largest of the second pass, and that's going to be the largest of the third pass. So we can stop. So it looks like J went from 1 to 2, or another way of saying that J is equal from 1 to n minus 3. So here we can stop and start this process over again for one more pass. So 2, 1, 3, 4, and 5. So here we compare the A1 entry with the A2. Is that true? It is, so we're going to swap. And we're going to get 1, 2, 3, 4, 5. And we know that those are already in increasing order, so we can stop here. So this looks like J went from 1 to 1. So this is J is equal 1 to n minus, what is it, 4. So here, this is our final list, and we can see that that is in increasing order. Okay. So notice that we have one pass, and on that pass, we scroll this way, right? And then we have another pass, and we scroll this way. Another pass, scroll this way, right? So it's actually, it's similar in structure to how we were indexing through the multiplication table example that I had. Okay? So let's look at the pseudocode for bubble sort. Okay, so name, bubble sort. Input, L is equal to A1, AN, and this is a list of numbers. The output is going to be the elements of L in increasing order. And the algorithm is going to be a nested for loop. Okay, so the way this is going to work is we're going to say for I equals 1 to n minus 1. So the I is going to be like the pass that we're doing, right? And then for j equals 1 to n minus I. So for each of these j, we're going to index through the list. We're going to have an if statement if a sub j is greater than a sub j plus 1, swap a sub j and a sub j plus 1. And then return L. So this is just if a sub j is greater than a sub j plus 1 right there. So notice that j, when we were passing through horizontally, doing the swapping, right, j was decreasing. And that's what's happening here. So for j is equal to 1 to n minus 1 is when I is equal to 1. That was our first pass. And then I increments to 2 after you pass through. So then from j is equal to 1 to n minus 2, that was our second pass of bubble sort. Right, we didn't need to go all the way to the end of the list anymore. And then we exit out, and then we increment I to 3. So from j1 to n minus 3, we pass down again. That was our third pass, right? So this is the algorithm for bubble sort. It's an algorithm you probably need to remember, especially I could see it being the kind of question where you might be asked in like an interview coding scenario to program this. Though in practice, it's not very fast. It's still a simple sorting algorithm that you will need to know. So let's code that now using Python. Okay, so then So let's just call this function to def, the function, bubble sort, takes in a list L. Okay, so n is equal to the length of L. So for I in range, say, be careful with the indices here. Let's say 1 to n. Now recall that the range function stops at this number -1. And then for j in range, say n -1, no, n minus I. And we want to start at index 0 here. Let's just say, I'm going to do a print statement here just so I can see the output. So print L, print L, J. And then this is not bubble sort. I'm just doing this to make sure I'm getting the indices correct. Because we're going to want to compare J and J plus 1. So exit out of that function, and I'll say L is equal to, what was the example I had? 3, 2, 4, 5, 1. 3, 2, 4, 5, 1. And I'm just going to call bubble sort on that L. Maybe need a space here so I can see better. Oh, my indent doesn't match there. Okay, so here's our list. And then L of J is there. J plus 1 is there. And then J increments. So here's L2 there. L J plus 1. And then J increments. So L of J plus 1. And then L of J plus 1. So that it goes all the way through the list there. So this is L of J right here on the first pass. And then on the second pass, it shouldn't go past this comparison. And it doesn't. And on the third pass, it shouldn't go past this comparison, which it doesn't. And then it should compare there. All right, so it looks like these are the appropriate range functions for bubble sort. So now, instead of printing these things, I'm going to swap with an if statement. So if L of J is greater than L of J plus 1, colon. Now, to swap at the same time elements, you don't know in Python, what you can do is simply do L of J, L of J plus 1, there's comma there, is equal to L of J plus 1, comma, L of J. So this will assign the LJ plus 1, and LJ plus 1 will at the same time be assigned to LJ. So that's equivalent to swapping. And then you just want to say return L. Okay. So, there, and then just say print L. Run it. And we see that it's been sorted in increasing order. Okay. So this is bubble sort programmed in Python. Now, you should keep in mind that, so if I call L, So Python has built-in sorting functions, so you can just do L.sort, that's a method, and then that'll also sort it. If you want to sort it in decreasing order, you can do L.sort. Again, these are built-in methods in the Python, and then reverse equals true. And if you look at L, now it's in decreasing order. That's just a method you should know about. But if you were to program a sorting algorithm from scratch, this is one way to do it using bubble sort. Right? I could even call bubble sort now because it's in my namespace. So, and now we used our algorithm to sort it back in increasing order. Okay, so that will be it for today's lecture. I will post this on my YouTube channel, so please be looking for that later today. Any questions? Okay, well, I guess that'll be it. Everyone stay safe, and I will see you guys on Thursday. Have a good day.